Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is 1,4-methylphenyl cyclopentane, which has a paramethyl group on the benzene ring and a cyclopentane ring attached at the ipso carbon. Moving on to the next step. Reaction with SO to Cl to HV, free radical chlorination. SO to Cl2 under photochemical conditions acts as a free radical chlorinating agent. Free radical halogenation occurs preferentially at the most stable radical site. The cyclopentane ring is attached to the benzene ring at a tertiary-like benzylic tertiary carbon. The one position of cyclopentane, the carbon bearing the phenyl group, is both tertiary and benzylic, making it the most stable radical site. Therefore, SO to Cl2 HV chlorinates the cyclopentane at C1, the carbon attached to the ring. Product A is equal to 1,chloro-1,4-methylphenyl cyclopentane. Moving on to the next step. NBS is a benzylic allylic brominating agent under radical or ionic conditions. In A, the methyl group on the para position of the benzene ring is a benzylic CH3. NBS brominates the benzylic methyl group to give a benzyl bromide, CH2Br. Product B is equal to 1,chloro-1,4-bromomethyl phenyl cyclopentane. And for the final step, KSH is a nucleophile, HS-. It will undergo SN2 substitution at the more reactive less hindered site. The benzyl bromide, CH2Br, primary benzylic, is much more reactive toward SN2 than the tertiary CCl at the cyclopentane ring, which would be highly hindered for SN2. Therefore, KSH selectively displaces the benzylic bromide to give CH2, while the CCl at the tertiary cyclopentane position remains intact. Product C is equal to 1,chloro-1,4-mercaptomethyl phenyl cyclopentane, which corresponds to option B. Para-substituted benzene with CH2 on the methyl-derived position and Cl at the cyclopentane quaternary carbon. Why other options fail? A. Has Br at cyclopentane and Sh at benzylic. This would require KSH to react at the tertiary CCl, SN2 disfavored, and leave the primary benzyl bromide intact. Incorrect. C. Has CH2Br remaining and Sh at cyclopentane. This would require SN2 at tertiary carbon over primary benzylic. Incorrect. D. Shows elimination product not consistent with KSH as nucleophile under these conditions. Incorrect. Therefore, the correct answer is B. Therefore, the correct answer is option B.